Hey, this is Mr. Markarian, reporting from my secret lair and headquarters here in Madeira. Today we're going to be calculating the base pH for both strong and weak bases. And so let's get to it. Here we've got a practice problem. It says calculate the pH of a 1 times 10 to the negative 3 molar solution of sodium hydroxide. So this one's pretty straightforward and clear cut. Sodium hydroxide is a formula of NaOH, so there's only one hydroxide that we have to deal with here. So as with anything strong, you want to take its negative log to get its pH. This one, if we take the negative log, since it's a base, we're going to get the pOH first. So the pOH for this thing is 3. To get the actual pH of the solution, remember we have to take 14, subtract the pOH, which in this case is 3, and it gives us a pH of 11. Okay, moving on, we look at this example, and it says calculate the pH of a 1 times 10 to the negative 3 molar solution of calcium hydroxide. This one has the same concentration as the last example, but you have to remember with calcium hydroxide, there are 2 hydroxide ions in it. So calcium hydroxide, if we look at it, we're going to take that concentration, multiply it by 2 to account for the 2 hydroxides. So we're going to get 2 times 10 to the negative 3 molar hydroxide in that solution. Again, take the negative log of that, and you get a pOH of 2.70. Again, to get the pH, subtract from 14. We're going to get 11.30 for the pH for this base of calcium hydroxide. And clearly showing that it's basic. Okay, let's move on to weak base practice. It says considering the following, you've got ammonia, water, ammonium, and hydroxide, and it says calculate the pH of a 2 molar solution of the weak base ammonia in water. The Kb is 1.8 times 10 to the negative 5. Kb's and Ks work the same way. They can really help us with these weak examples that we have. So let's take this one apart piece by piece. First thing is always make sure to set up that equilibrium expression. This time it's a Kb, which is going to have the products ammonium and hydroxide at the top and the ammonia at the bottom. Water is left out because it's a liquid. Next thing I do, step 2 in all of these, is set up my ice table. If you don't need the ice table, that's fine. You can, if you understand the setup and how it works, you could skip the ice table. It's not required to be put in there to get the answers correct. Once I have the ice table, I can plug those values back in. Now, notice with the ammonia, I did not take into account the minus X. Everything is 1-to-1 in this, but that minus X is going to be a minimal amount. So I'm going to go ahead and use the 5% rule and ignore it for now, just like I would with a weak acid. The Kb is small enough at 1.8 times 10 to the negative 5 that we're going to be okay. And if you do the 5% rule thing that I taught you in class before we left, that should help you out. Okay, so we have the numbers plugged into our expression. We get x squared over 2 equals 1.8 times 10 to the negative 5, which again is the Kb. Solving for x, we get 6 times 10 to the negative 3 molar hydroxide. Remember, if you negative log that, that gives you the pOH, which is 2.23. How do we get the pH? Subtract from 14. And in this one, we have a pH that is 11.77, which is clearly basic. Okay, so that's how to do the strong and weak bases. They're very similar to acids, but I thought I'd throw this in there just so you're not confused by the notes, or if any questions come up, you've got a little bit of help there. Make sure to email me or message me on Remind if you've got questions, and I will answer them as I'm sitting here waiting for us to go back.